insertion sort is already like all the data items arranged in one at a time. One at a time means, see here, maybe if you're having multiple cards, you have cards in the hand. You are taking out the cards and you are that particular, maybe the second position, you take the card and you insert the another one element in that second position. So where you are taking an item and you are putting, you are making one element as a key, that's the main part over here. And you are inserting another one element instead of that particular element. So here what is that is, see here, insertion sort is just a symbol sorting algorithm, and it is very less efficient than your quick sort, heap sort, merge sort, everything. But it is more efficient than your selection and bubble sort, because here there will be two steps called as, you will select, then you will compare, you will shift, and then insert. So that how it comes along, I'll tell you. So first important thing is your key selection only. Always your first key element will be the A of 1 only will be your first key element. A of 1 means your second element, 0. So 0th element, leave it out. Your always your second element will be your mostly your key element of your this insertion sort procedure. Your second element is your key element. So when you take the key element, you will be comparing the key element with the previous elements in the array, not the next elements. With the previous elements you will compare. That is what. Choose the key element, then you compare with the previous element. If your key is smaller than the previous element, now you have to swap with the previous element until your key will be getting replaced in the correct position. So for that only we'll be using while loop and everything, that we'll see it. Else you will be just changing the, else if this is not the case, now if your key element, if your previous elements are not lesser than your key element, you have to choose your next element will be, for example, if your key element is A of 1, your next key element will be A of 2. Then again, if A of 2 is your key element, your next element will be A of 3. Likewise, it goes on. So repeat until your n minus 1th element becomes the key. Why it is n minus 1 element? Because the first element is not at all taken as a key. So the remaining elements will be n minus 1 only. So I'll show with an example which makes you more clear. See here, 8, 2, 4, 9, 3, 6. Okay, example of insertion sort. So here I am taking the second, 1 minute. Yeah, I'm taking the second element as the key element. And what happens is, second element you have to compare with the previous element. Here the previous element is only 8. So 2 will be compared with 8. 2 is actually 8 is smaller than 2, right? 2 is smaller than 8. So what happens? 2 will be getting replaced, swapping. So 2 and 8. So initially, listen here very carefully. Always second element will be taken as the key element. That is compared with only the previous element, not the next elements. So 2 is compared with 8. So what happens is, it is less. 8 is greater. 2 key is smaller. So it will swap now. 2 and 8 gets, 2 will be here and 8 will come over here. Now your next key element will be, since your key element is A of 1, this is A of 0, A of 1. Your next key element will be the next A of 2. Which element is in A of 2 only will be the key element. So now this and this gets swapped. Now 4 is your next key element. Now what happens? This key will be compared with 4 as well as with 2. So when it is compared with 4, it gets swapped. See here. Because 4 is lesser, it gets swapped. Then it is 2 is already in sort. It is in the correct position actually. So, but anyway, comparison happens. It will compare. It is in the correct position. So it will leave it out. Now what next? Now initially your 2 was your key element. Next 4 was your key element. Now your next key element will be incrementing plus 1. So 9 is your key element now. Now 9 will be compared with 8. 9 is greater. Compared with 4, it is greater. Compared with 2, it is greater. So it will remain in the same position. So 8, then 4, and this arrow mark has to come till here. So it will compare it and it remains in the same position. Now again your next key element is 3, because first this was your key element, next this, next this, next this. Now 3 will be compared with 9 first. It will replace. What happens is 3 will be compared with 9. So 3 will come in this position. Again, this key element will be compared with 8. It will move to the, until it gets inserted in the correct position. It will keep on comparing. Again, it will come here. So once again, there is smaller, key is smaller. It will come here. Again, it will compare with 4. It is smaller. It will come. It will come here. But it does not know what. See, whenever a key element is getting replaced in its correct position, normally it will be inserted in the correct position only. So again, this is already now left side will be, see, when you choose a key element and when you make compare with the previous, you can find that your your left side will be always in the sorted order. Now see, your next element will be 6s, because till 3 we have taken as the key element. Now 6 comes up. When 6 comes, once again 6 will be compared with 9, it gets replaced. 6 will be compared with 8, it will be replaced. So the other elements are already in the correct position only, but anyway checking happens. So, but there will not be any swapping. So finally what happens is your final, all the elements are getting sorted. Any doubts regarding this example?
No.
Okay. So insertion sort, two things you have to keep in mind. Insertion sort, one is your key element. That is your always your second element will be taken as the initially as the key element. When the second element is being taken, initially it will be compared with the previous element only. Then after that, your key element will shift to the next position. Then again it will be compared with the previous elements. So next it goes on until it gets sorted. Your key element will be incremented one by one. Once it is sorted, your algorithm ends. Okay, and so this is what with the final thing, final with the base of key elements I have marked over here. It is done. Now see here, in insertion sort, key is an important position where it takes the role. So your array will be always the key element. Array of 1 will be 0. It starts with 0. Array of 1 will be your key element. And j will be I minus 1, where you have to move the elements greater than the key. So 1 will be taken with I part, and another one will be taken with the j part. See, I want you people to work out these algorithm by taking with an example. Okay, and you have to show it to me during the lab session, so that only when you take an exam, when I can explain it like this, like for loop, it takes this particular element and key element is taken here, and your I will be decremented, so that for comparison, for swapping we need ij, so for the comparison we need that. So again, if your index is greater than 0 and if your array of j is greater than the key. So here actually I have one example which I have worked out. If there is time, I will show you that also. After taking selection sort, I will project that and show it actually with an example I have worked out. For DAA we have worked out, because to show the analysis, normally we'll be working it out, then only analysis will be clear. So if time is there, I will show the working part of this in the after taking selection sort, or else in the lab time at least I will show you. So while j greater than 0 and this key, this is for the comparison. So this is where you are checking it out, where you swap it out. Swap the array of the j and j plus 1, where swapping happens. So this loop will be incremented until it takes the correct position, and finally you see here your j plus 1, that is, this is for getting it into the key, getting replaced it into the correct position, for where the key get replaced into the correct position. For that only this line is there. When this comes out, this line will get executed. Okay, so this working I will show you after taking one more sort. I'll take that slide and I'll show it to you. So now the time complexity, here also we are using n times. Here also this swapping happens n times. So normally sorting all, mostly it will be O of n square only. one it will take for the comparison, and one it will take for your swapping. So average case and the worst case, normally the case time complexity itself will be O of n square only most, yeah, except your merge, and at that time I'll tell you merge quick and everything what it happens. But mainly the other normal sortings will be of your O of n square only for sortings, insertion, bubble, as well as selection, because the same concept only will be repeated with only one change. In bubble, 2 by 2 numbers will be compared. In insertion, a key element will be taken and that will be compared. And in your selection, it will select the minimum element, and then that minimum will be replaced with the position, first position, second position, etc., etc. So this insertion, as I told you, this is best than bubble and selection, but it works for only small data sets, and it is less efficient for larger list of elements. Okay, I'll finish the selection sort first. So here in selection sort, you are first taking the smallest element in the array, then you have to exchange it with the position. Exchange it with the position with the current thing. So you have to continue this until your array is getting sorted. So see here, 23, 78, 45, 8, 32, and 56, original list. Now, see, first element, you have first, initially minimum element has to be taken out, right? So normally when you go start with the array, you will be taking the minimum element as first element only, will be you will be assuming as the minimum element. Then using you have to compare this element with each and every element to find out actually what is minimum element in the array. So I think you know about to find how to find the minimum element. So when I look into, I can tell you that 8 is the minimum element. So when I take 8, what I will do is, now this 8 will be compared with the already which is assigned as current element. Current minimum is 23, I have told, but actually your 8 is the minimum. So now this and this will be compared now. Comparatively, 8 is lesser. So what happens is 8 will take the place of this 23, and 23 will take the place of 8. Then after pass 1 again, this is so when you replace, you can see that your left side will be in the sorted order. So when again now your minimum element will go to 7, current minimum will be taken as 78, but actually your minimum will be 23. So there is a comparison where to find the minimum. When 23 it has found, 23 and 78 will be now getting interchanged. Similarly, next minimum, initially it will take 45, but actually it will compare for the other passes. For the pass 2, it will compare with the other element. 32 is minimum. So 32 and 45 will be interchanged. Then again, it will choose the next minimum 45. 45 and 78 will be interchanged. Then 56. So 56 and 78 will be interchanged. So here, the main thing is, first you have to find the minimum element. So when you want to find the minimum element, just like that, algorithm will not go and jump and find the minimum element. It will be assuming the first element as the minimum, and that element will be compared to each and every element in the array. When it finds an element which is lesser than the current element, it will replace the minimum element as the lesser element which is less than the currently chosen element. So then this is how the algorithm works. See, another one also I'll tell you. One is taken now, but this is just by visualization I'm telling. One is taken as the minimum, one, and which one will be replaced? 8 will be replaced, because that is the first position for us. 1, 8 first. Then this 4 has to be replaced with the next minimum, that is your 2. Next minimum is 2, that will be replaced with 4. Then here this third now, because this will be sorted in order only. Then this third place when you take, you have to find the next minimum is 3. 3 and 6 will be swapped. 3 and 6. Next minimum with the fourth element, 4 here. 4 and 9 will be swapped. Then next is 6. 6 and 9 will be swapped. The next 8 and this will be swapped. So this is how you have to find 8 and okay. So finally the sorted element comes up. So when I come here, in your selection sort, you see I to n minus 1, minimum element. First, you are initializing as the first element only, setting the current element as the minimum element. So, first element you are taking is the minimum. Check the element to be minimum. We have to know whether the element which we have chosen is minimum or not. So, what we have to do is, then you have to keep on, you are using another variable j, and you are keeping on comparing whether your next element and the element which you have chosen, minimum element, is lesser, or if your chosen minimum element is lesser, it will retain in the same place. Otherwise, in your the rest of the array, the minimum first element is taken as the minimum element, and the remaining all elements after its comparison based on this condition, if it finds the minimum element, then that is j variable is used for comparing the rest of the element, and I will be the first minimum here. So now when it compares with the remaining elements, if the element j in any of the j array, if the element is lesser, that will be now taken as the new minimum. So in your previous case, you can see first I was 8, and this will be j will be keeping on moving. When it finds j1 as the minimum element, that is j, this and this will be replaced. That's what this line. If your list of j is less than the list of the minimum element, minimum means the current which you have chosen, that will be assigned as the now the new minimum. If your j element is lesser, then it will get replaced, it will replace I in place of j. Now you can go for the swapping. You can find out the swap the minimum element with the current element. Okay. So this is what actually your selection sort. So with this, what I'm trying to tell is only 3 sortings as of now I have taken, and time complexity as per the same. Since we are finding the minimum element, your best case also will be n square. So normally, whatever, if they ask you the time complexity of selection, bubble and insertion for MCQs or whatever they ask, you have to tell it as O of n square.